All right, let's jump right into it. Today, we're tackling a huge question. How in the world do you make a self-driving car truly safe? We're going to break down the whole complex process, layer by layer, to see how the industry is trying to build what you could call a shield of trust around this incredible technology. And it really all starts right here with this idea. This isn't just some nice-sounding corporate goal. It's the absolute core mission. Because let's face it, without public trust, the most advanced self-driving car in the world is basically just an expensive garage ornament. This one sentence frames our entire conversation. It's all about delivering a safe journey. So here's our game plan. We'll start with the biggest hurdle, this trust problem. Then we're going to build that safety shield with 3 really important layers. After that, we'll get into a tricky question. What does safe enough even mean? And finally, we'll see how all these pieces have to fit together perfectly to create a complete safety ecosystem. Okay, so let's talk about the biggest roadblock for autonomous vehicles. And you know what? It's not really the technology. It's us. It's public perception. I mean, despite some absolutely mind-blowing engineering, a few high-profile accidents, especially back around 2018, created this massive trust deficit that the industry is still working really, really hard to overcome. And that brings us right back to that core mission. For the AV industry, earning our trust isn't just a nice thing to do. It's about survival. It's an economic necessity. If you and I don't feel safe, we're not going to use the service. And if we don't use it, this entire multi-billion-dollar industry, well, it just fails. Simple as that. Okay, so how do we actually build this shield? Well, it starts with the very first layer. Functional safety. This is the foundation. It's all about making sure the car's own brain and nervous system, its hardware and software, don't suddenly fail in some dangerous way. The official rulebook for this is a standard called ISO 26262. Now, its goal is pretty straightforward, but absolutely critical. Make sure all the electronics that keep you safe either work exactly like they're supposed to, or if they do fail, they fail gracefully. They fail in a predictable, controlled way that doesn't cause a catastrophe. Think of it like the system's own internal health insurance policy. So how do engineers actually do this? They use a process called HARA, which stands for Hazard Analysis and Risk Assessment. They basically go through this checklist for every single component. They ask, what could go wrong? How bad would it be if it did? How often will this happen? And could a human fix it? The answers give them a risk level, which tells them exactly how bulletproof that part needs to be. This all sounds pretty solid, right? I mean, if all the parts are guaranteed not to break, the car has to be perfectly safe. Case closed. But what if the problem isn't a broken part at all? And this slide hits on a really critical gap. On the left, you've got your classic system malfunctions. A sensor breaks, a bit of code crashes. That's what functional safety is for. But look at the right. This is a totally different beast. This is when every single component is working perfectly, exactly as designed, but the design itself leads to something dangerous. And functional safety has no answer for that. And this is where the second layer of our shield comes in. It's designed to solve that exact problem. It's called Safety of the Intended Functionality, or SOTIF, and it tackles this fascinating, kind of tricky question. What happens if the car does exactly what we told it to do, but doing that thing is still the wrong, unsafe move? So, of course, we get another standard, SOTF. Its entire reason for existing is to hunt down and fix risks that come from the limitations of a system, not its failures. It's all about those weird edge cases, those known situations where the system might get confused, and the unknown what-ifs it's going to run into out there in the real world. Here's a perfect example. Picture this. A car's camera is working flawlessly, A+ performance. But it drives into a patch of super dense fog, and its programming just can't make sense of it. It misinterprets that fog as a solid wall and slams on the brakes. See? Every part did its job based on what it thought it saw, but its perception of reality was just wrong. SOTIF is all about preventing these kinds of design-based mistakes. So our shield is getting pretty strong and now protects against internal failures and design flaws. But there is one more massive vulnerability we have to patch. What about threats from the outside? And that brings us to our third and final layer, cybersecurity. You've heard it a million times, but a modern car is basically a supercomputer on wheels, and it's almost always connected to the internet. Well, that makes it a juicy target for hackers. So automotive cybersecurity is about building a digital fortress around the car to stop anyone from getting in and causing trouble. Because without this layer, all our other hard work could be undone in a heartbeat. And just like our other layers, this isn't the Wild West. It's all guided by some very strict standards. The whole point, as you can see here, is to make sure security isn't just an app you install at the end. It has to be baked into the vehicle's DNA from the moment it's just a sketch on a screen, all the way through its entire life on the road. So, we've built our shield. It's got 3 powerful layers: functional safety, SOTIF, and cybersecurity. But this leads us to a really fundamental, almost philosophical question. With all of this in place, how do we actually decide when a car is safe enough to put on the road? We have to be realistic here. Perfection is impossible. Zero risk is not an option. Not in cars, not in planes, not anywhere. So the real question for all of us is, what level of risk are we as a society okay with? What's the acceptable trade-off for a machine that drives itself? Now, to put that question into perspective, let's just look at some numbers. Right now, the odds of dying in a car crash are about 1 in 114. That's pretty high. Now compare that to getting struck by lightning in your lifetime, about 1 in 15,000. These are the kinds of risks we just sort of accept every day. The goal for AVs is to be way, way better than that human driver baseline. And if you want to see a truly mind-bogglingly high bar for safety, look at the airline industry. The FAA has set the acceptable risk level for a catastrophic failure on a plane at 1 in a billion. 1 in a billion. Now, it's not a perfect comparison, but that's the kind of incredible standard the AV industry might one day be measured against. But here's the catch. Having all these standards and actually achieving safety are 2 very different things. This quote really nails it. You can't just follow a recipe and get a safe car. These standards are the map, but the car companies themselves have to actually design and engineer the safe journey. So how do they actually do that? How do they build that safe journey? Well, it's not about treating these safety layers like items on a to-do list. It's about creating a huge, interconnected safety ecosystem where every single part works together from day one. And this is what that whole ecosystem looks like. It is so much more than just the car. It means tracking every single line of code. It means using insane simulations to drive billions of virtual miles before ever touching a real road. It's about using the right tools, connecting all the data, analyzing it. It's the whole shebang. Our 3 safety layers are a huge piece of the puzzle, but they're part of a much, much bigger picture. So the ultimate takeaway here is this. Real safety isn't something you can just bolt on at the end of the production line. It has to be woven into the very fabric of the vehicle from the start. That mission of a safe journey is only possible when all these critical layers are part of the process from the very beginning. So together, functional safety, SOTF, and cybersecurity, they form this powerful multi-layered shield designed to protect us. The engineering is incredible, the standards are tough, and the goal is clear. Which leaves us with a final, and maybe the most important question of all. Are you ready to trust what's behind it?